supposed to find your own data. So don't simply get data from books. Okay, you can able to identify the source data. So because I want you to apply what you have learned, if you simply want to avoid a problem by looking the data that are free from any problem, then there is not. It's not the right way. Okay. But if they say your data really don't have any problem, then okay, now you just explain. They say you perform all the tests, but it's quite unlikely it's possible, but it's possible. So if they say there is no, you perform all the tests, heteroscedasticity, autocorrelation, multiplication, all are okay. Then okay, now you just explain, so all are fine. So you don't need to do any remedial measures. Okay, but again, it's good that you can apply what you have done now. So let's say you find data that is not perfect, that requires you to do something, and then you can apply. You can apply what you have done. And then for if they say some of you want to use RDL, whatever, that is RDL. Remember, autoregressive distributed model. If you want to perform the bound test, you need to make sure that there is no I2 data. So you have to perform your root test, speculative test to make sure there is no data, there is no variable that is integrated of the two. So either I0 or I1 only. Okay, for area. Assignment, you examine the report as well as the soft copy of the two spectrum, so as well as the data file in abuse, data in abuse. So before we do lab session 10, so I just want to know how many of you had a bachelor degree, first degree in economics? I want to know whether you have a good background in economics. So or not? In finance. The others? Did you do your bachelor degree in economics? Finance coordinator. So all of you, so what are the degree that you obtained for the first degree, bachelor degree? Engineering. I think some of you, but you just don't want to raise your hand. So again, how many of you have a bachelor degree in economics? Raise your hand. I just want to know. One. Those who are doing master in development studies, I think you should. You're supposed to have a degree in economics, right? The morning I will not ask you to come here and do the exercise. I just want to know. Okay. Alright, now let's session 10. So we have about 8 questions. Okay, so this one, the first 7 questions just on explanation. So the first one, what is meant by simultaneity problem? The one as explained in the national. So I think you can decide this one. You can just read the given answers. The mutual dependence of variables in the regression model leads to the simultaneity problem, meaning that you have more than one variable that can be treated as dependent variable. The one we have simultaneity problem. y on the square aim operates to estimate an equation embedded in simultaneous equation model. So this is because the correlation between the error term and one or more of the arithmetic variables included in an equation in model. Okay, because of the when there is simultaneity problem exists between variables, and then it will make your there will be correlation between regressor and the error term. So because it's one assumption of the ordinary square requires there is no correlation between regressor and the error term. So 3. So what happens if ordinary square is applied to estimate an equation in a simultaneous equation model? Because of the correlation between the error term and the explanatory variables in a given equation, within a system of simultaneous equation, the ordinary square estimator are likely to be biased as well as inconsistent. Number 4, explain carefully the meaning of this one just now. Identify, meaning that we can estimate by the coefficient. Exactly identification or exactly identify, so we can estimate using both ILS and what we call that 2 square, and our identification can be estimated using ILS. Okay. So in a system of simultaneous equation, if we cannot estimate the parameters of an equation in the system, the equation is unidentified. If we can obtain the unique values of the parameters of that equation, it is exactly identified. However, if we obtain more than one value for one or more parameters of the equation, the equation is unidentified. 5. What is method used to estimate exactly? So you can use ILS as well as 2 square. So here you mentioned that if x equal, so n exactly equation. Exactly identified equation can be estimated either by the method of indirect square, ILS, or by the method of 2 square. Both methods will be the same. 6. What is 2 square used for? 2 square is primarily used for estimating the parameters of an over unidentified equation. But it can be used for to estimate for exactly identified equation as well. 7. Consider following 2 equation model. So we have this and this, where y are the endogenous variables, the x the endogenous variable, and u the stochastic error term. Obtain reduced form regression. So if you identify which equation can be identified based on the order of identification, our m, just like before, so we have 2 dependent variables, so we have n equal to 2. We have 2 endogenous variables. So in total, we have how many variables? We have y1, y2, x1, x2, so 4. 4. In total, we have 4 variables. 2 endogenous, 2 exogenous. Okay. So the first equation, it is what? Can be estimated. It is arbitrary. Exactly identified, over identified, or unidentified. Exactly. So we have 1, 2, 3. Okay, 3. So k equal to 1. K equal to 1, so equal exactly. Identified. Second one, because the second equation also the same. Okay, second equation is exclude x1. First equation is exclude x2. So both can be estimated. Both are exactly identified, so we can estimate using both ILS and 2 square. So obtain the reduced form regression. How to obtain reduced form regression for the first equation? For the first equation, to get the reduced form regression, you have to replace the endogenous variable or the endogenous variable that appears as your regressor should be replaced with its component, so that after you replace, eventually the regressors only include or involve the exogenous variables only. Okay, so you have to replace me, you have to put this one. So this one you have to put here. And you rearrange and you get your reduced form equation for the first equation. Then you also can do for the second equation, you replace y1 with the component of y1, this one you put here. Okay, and you arrange, you get reduced equation. Reduced form regression for both equation 1 and equation 2. So for the indirect least square, you have to identify reduced form. You have to produce reduced form equation for all equations, even though some of them are under identified. Okay, you have to do for all. And then you estimate the reduced form equation, and then you make use of information. Later we do an example to calculate or to get estimate for the coefficient of the equation that you can identify the values of parameters. So for A, this one, okay, so we need that. We have to value this one for the parameters, the 7. So where these parameters equal are all the reduced form coefficient, which are combination of the structure coefficient, the A and B's, the coefficient, and where W and B are the reduced form terms. So identify which one can be estimated, B, and determine which of the equation is identified. So here we have two evidence variables, y1, y2, and the two evidence variables, x1 and x2. By the order condition, both equations are exactly identified because each of the equations exclude one variable. So k equal 1, which is equal to n minus 1. So equal, so exactly identified for both equations, equation 1 and 2. C, for the identified equation, which method of equation would be used? So you can use IS, but remember, exactly identified also can be estimated using 2 square. So use IS and or to plus you can use. Okay, but IS can only be used for exactly identified. Now let's say, suppose a priori is known that A2, this one is 0. How would your answer to the preceding question change? Why? So let's say A2 is 0, so we don't have this one. So which equation now can be estimated? Which one cannot be? Which one can be identified? Which one we cannot? Let's say we don't have this one, so this one A2 is 0, so we don't have this. So which equation now can be identified? So in total we have 3 variables, y1, y2, x2. Right, so we have 3. M, same lah, m equal to 2. So the first equation, it excludes 1. Right, so the first equation is exactly identified. Second equation, it is under identified because it excludes none of the variables, so it has all. Okay. So if they say A2 0, then only the first equation can be the parameters coefficient can be identified. So I'll explain here. Okay. So the last question. So consider the following two equation model given in the AVIUS data file. So we have two equations. So how to know? Let's say you have let's say you collect data, then how to know whether there is simultaneity between variables? So one way you can refer to the available for existing theory to check. So what's the possible influence whether we have, let's say, you collect a set of variables, then you have to check to consider the possibility of having simultaneity between variables. So you have to use, if there is a theory suggests that basically there is a test available, but we will not discuss that. So basically there is possible, it's quite tedious to do. So there is what we call as the Hausman test of, I think, specification, something like that. So it's possible to perform a test. You believe, let's say you believe there is possibility, or you expect there is possible for the simultaneity between variables, and then you want to know whether there is whether you should use simultaneous equation or not. Then you can perform definitely one you can. I leave it to you to explore. So there's the one possible method, the one that we call as Hausman specification test. Hausman specification test. Okay, we can use to check if whether the variable correlated with the other term or not. If variable, your independent variable correlated with the other term, and you have to use this technique. So 2 state square or as you can use the square. Okay. So that's important for you to check the existing or available theory. Okay, in order to don't just simply regress, you have to check the possibility of having simultaneity between your variables. Alright, so here we have 2 equations, and as given here, or based on the theory suggests that so the interest rates depends on money supply as well as the income Y, and then the income at the same time also depends on the interest rate and the investment, I investment. Okay. So estimate parameter of the identified equation using 2 state square. So first you have to identify whether we can estimate parameters or not. So now we have in total how many variables? YT, RT, MT, IT. So 4. We have 4. In total we have 2 variables. We have 4 variables. 2 are endogenous, 2 are exogenous. So the first equation we have 3 variables, so it excludes 1. So it is exactly. So this one is exactly identified. Okay, exactly identified. Second equation also exactly identified. So basically for these 2 equations we can estimate, and we can get estimate using both indirect square as well as 2 state square. Okay, both can be used to estimate. Now let's use the 2 state square first. Estimate parameters of the identified equation. So both are identified, exactly identified. So we use the 2 state square. So we have the variables, which is 8. So to estimate the first equation, what you need to do, in order to estimate using 2 state square, for the first equation, what you need to do, the first stage you need to do what? You need to find a proxy for what? So now our independent variable R and Y. R and Y are our endogenous. So you have to find a proxy or instrumental variable for YT. So that can be done by using fitted value of Y. Okay. You have to, instead of using Y, you have to use fitted value of Y. So the first step step 1, you have to get y hat. How to get y hat? You have to regress y against all exogenous variables. Okay, so what are our exogenous variables? M and I. Okay, so you regress, the first stage, regress y against M and I. Okay, so you get your y hat, you go to view. You understand what's y hat? What's filter value? Filter value, I mean, you write the filter equation, then y hat, when you replace the value of x, then you get y hat. You go to view, actual filter is equal, table. So use this one, filter value. So copy this one, and then you create a new object. Copy this, create new object, new object, series, name it as y hat. Okay, so you open and you click edit, paste it, paste the y hat, the filter values. Okay, so click edit again before you close. Now you can do the second stage. Okay, the second step is to regress or to estimate the model, to estimate this one, but instead of using y, you use the y hat. The m, you can use the original one. The m, because it is endogenous, then okay lah. And this one exogenous, then okay. But this one because endogenous, and this one endogenous, so you have to replace with the filter values. Okay. So the second step, you estimate model, you regress R, C, M, and y hat. Okay. As the previous one, equation 1. So this one, equation 2. So we get estimate for the parameters. So we have A1, A0, A1, A2. So A0, A1, A2. Okay. Or if you use, you can, this one if you step by step manually, you also can use if use just like what we did before. You go to quick equation. So this one you can just use, you can just type all. So you have R space M space Y. Now Y hat and Y. But then you select 2 states square, and then you put your in the exogenous variable. So we have M and I. M and okay, so you get the same estimate lah. You get the same estimate, but different p value lah, because I think you use different, because where we do manually we use y hat, not y hat. So this one we use different way to calculate the statistic error and so on. But perhaps this one more reliable than the estimate. So the first equation we managed to get estimate. Okay, and now second equation. The second equation, the first step, you need to get what? You need to get proxy for R. I okay, because I is exogenous. So this one, because one exogenous, you can find a proxy or replacement for R. So estimate equation R space C space M and I. So regress against an exogenous variable only, exogenous variable only. Okay, and then so you have interview, actual, beta receiver. So you get the R hat here. So this is our R hat. Beta value for R. So you create new object, new object, series. You name as R hat. Okay, so you paste the beta values. Open R hat, click edit, paste. Okay. Now you can do the second step, stage 2. Okay, stage 2 you regress y against R hat and I. Okay, y against R hat and I. So you have Y space C R hat and I. Okay. So you get this estimate for the second equation. Beta 0, B0, B1, B2. So in views, you have views, then you can estimate that easily. You just regress y against R and I, select 2 space square, T as LS, then you put M and I, the exogenous variables. Okay. Okay, so you get the same estimate. Okay, the last one. B, estimate parameters of the second, but this one you actually can use the indirect square to estimate for both. But for this example, we just do for one. Okay, just do for the second equation using indirect square. So indirect square, what you need to do? Remember the step indirect square for the second equation. What you need to do? First step, you need to identify or convert these two equations to the equivalent reduced form equation. So identify form reduced form equation for both equations. Not only one, for both. For all. You have three, you know. Okay. So it is quite tedious to do, but that's one of the possible way to estimate. So you need to form reduced form equation, in which in that reduced form equation there is no endogenous variable as independent variable. So you have to remove the endogenous variable from the independent variable. So your independent variable, after you form the reduced form equation, it only contains or consists of exogenous variable only. Okay, that can be done by, for the first equation, to get reduced form equation, you have to replace the yt. Okay, yt is endogenous, so you have to put this one up. You have to replace yt with the component. So this you put it here, and you arrange. Okay. For the second equation, you can do the same. You have to replace rt with the component. So rt is one. You put here rt, and then you arrange. You get your what we call as reduced form. So this one, okay. So for the first equation, this is reduced form equation. So the intercept is given by a0 plus a2 b0 over this one. Okay, and then the coefficient, the slope parameter for mt, a1 over this one. Slope coefficient for it, this one over this. Okay, so for second equation, this one. So after that, you estimate estimate the reduced form regression for both equations. So the first one, you regress R against M and I. Second equation, you regress Y against M and I. Yeah. So basically the same is quite similar to the previous one. So if you so the first equation, you regress the first reduced form equation, you regress R against M and I. Using the OAS number square, so you get this. Okay, so 7. And then you do the same, you regress Y against M and I, you get 1. Okay, you get this. So from here, you get your estimate for each of these, for each of the coefficients in the reduced form equation. So you have the intercept for the first reduced form equation, for the first form reduced form equation, intercept slope for M, slope for I. Okay, so you take from here. And then second reduced form equation given by this. The intercept given by this, negative 238. Okay, and then the slope for M, the slope for I. And then you use this information to get estimate of the parameters for the identified equation. Okay, but in this case because both are identified, so you can get estimate for all A0, A1, A2, B1, B0, B1, B2. Okay. If only some of the variant equation are identified, and then you just use information to find estimate for that one. Okay. So how to get estimate for the original value of parameter A0, A1, A2. So you have to solve this one. So this is an example. So you make use of the information to find estimate of B1. Okay, so if you use this one, if time this one, so you can see that this one cancel out each other, and this one, and then leaving us this one cancel, so this one cancel this one, and then we only have B1, A1 over A1, so A1 cancel out each other, so you have B1. Okay, so use the information to calculate. You get negative 285.42. Basically the same like before. But this one you have to calculate. So B2, if you use these three information, and then you will be able to get this one. So for the B2, just to show how we are able to get these two from here. Okay, and then after once you get, so So you get B1, then use that one to solve this one, and then for the B0 also use the B1 as well. So it's quite tedious to do using indirect square as compared to two-stage square. But two-stage square requires you to estimate. It requires you to perform that using induce. Okay, so but indirect square, if information is given, then you can calculate. But it's quite tedious to do that. So again, this one as homework, try to do the same for the second equation. And this one for second. For the first equation, try to use direct square to find solution for A1, A0, A1, A2. Okay, first try to figure out. So next week we only have one topic to discuss. So the distinct profit model. And then week 14, you do your quiz, 10%. And then final exam. So exam open book as just like before, but it will be conducted in exam hall. So there will be no computer for you to use. You cannot bring any electronic device, smartphone, laptop, tablet cannot be. You cannot bring in. You can only bring in the printed materials. You see all the materials given in spectrum you want to print, and you can bring in. For example, this one you can bring. Okay. You can bring in, and the printed version you cannot bring the soft copy. Okay, electronic version. Okay, so please try. Maybe later on there are two things that I want you to try at home. Try to estimate using indirect square for the first equation, A0, A1, A2, and then try also to perform use to estimate using two-stage square for the case of the equation that is under-identified. See what happens. Okay, if they say the equation is under-identified, you try to estimate using two-stage square, then what the warning or the classification given by English. Try to do that. So we have an example before, right? Example 2, I think, 4. One of the example we have one equation is under-identified. So we can identify. So try to get that estimate using and see what happens. It is very used. Alright, so that's all for today. So see you next year.